Hello everyone, and this is Lab 1 from Physics 2211 at Georgia Tech, and this is to study the constant velocity of a moving object. So to start off, here are the contents of this video. First an introduction, then a ball motion analysis using Tracker, then a computational model using GlowScript or Python, then comparing the results from the two analyses, and then lastly answering some questions. So to start off, this lab aims to model the motion of a rolling object with a constant velocity. Some of the key ideas that we'll be using is Newton's first law, which says that an object's motion won't change unless a force acts on it, and also some kinetics formulas to find the final velocity and final position. The key assumptions that we're making is that there's no net force acting on the object, which leads to it having a constant velocity, so air resistance and friction will both be ignored. Here's a video, the initial video of the rolling ball. So to analyze this video using Tracker, it shows the ball in the video and can calculate its relative position at different times. So this data will also be used to create the computational model, at least for the initial and final, the initial position and velocity. So the steps for the Tracker analysis is to first import the video of the rolling ball, then to set the coordinate system. So since my video was at a different angle, I had to change the coordinate system as such. Then, since the ball is a system in this case, we consider it a point mass, so that boils it down to a single point with mass and space. Then shift-clicking on the ball at every frame at an equal timestamp difference will allow the Tracker app to create a simulation, and it creates the graphs. So this is a video of the Tracker analysis. You can see in the graph up here that the position change of the ball is constant, and the Y position can be ignored because those are microscopic differences during the shift-click process. You can also see the values in the table right here. So next, onto the computational model. The average velocity was calculated using the base numbers from the previous Tracker model, and this will be used to create an ideal version of what that motion would have looked like. So you can see the code right here. This is to create the visualization, and if you go down, these are the formulas that were used. Highlighted are the two formulas that correspond directly to the kinetics formulas in the introduction, and you can see that F net is 0, meaning no force is acting on the object. And that is the simulation that it created with a constant velocity. Also note that the velocity is negative because with the coordinate system, the ball was technically moving in the negative x direction. So now on to the comparison. Here's the model from the computational model, and here's the model from the Tracker app. So if you look at the two models, they are very similar. In fact, you can see that the slope is pretty much equivalent on both models. However, the timestamp on the Tracker model is a little bit different. It starts at 1.2 because it's at that many seconds that the ball rolling actually starts, whereas this one is more of an idealized model. However, the slopes of both is still the same. And you can also see the constant velocity, and going through the numbers on the Tracker model, it is pretty much the same as well. So on to the questions. So for the what if questions, these are the questions that were asked. So the answer to those, due to the camera angle, the table surface appears to be on an incline. However, it's not, it's completely flat. But if I were to use the standard XY coordinates that were horizontal relative to the camera rather than the surface of the table, then there would have been a motion and velocity in the Y direction as well as the X direction. But due to me changing the coordinate system, I only saw the movement in the X direction. If I flipped the direction of the X's, then my velocity would have been positive rather than negative, but the slope would have been the same absolute value. This means that the main force acting on the ball during motion is gravity. So to sum up the forces, gravity and normal force of the table would cancel out, and the friction and air resistance we're considering negligible. So the forces would add up to net 0. In real life, it would probably have been close to net 0, but not exactly. So yeah, thank you for watching my video. Peace.